Me too. Welcome everybody back to the Swift and SwiftUI Learnalong. This is episode, wait for the scroll, episode 33, yeah? 30, yep. Episode 33, so quick intro for anybody that's coming across the stream. I am doing this stream as a form of what I call fly on the wall learning, so first of all, I barely have any followers, so I don't expect much engagement. But also, in case that changes at any point during this stream, just know it's intentional that I'm not really interacting with the chat, because this really is me learning Swift for the first time. So everything that I've learned about Swift has been done on this stream, and it's been done in a fashion where I read out into the ether, so read out loud this Big Nerd Ranch Guide on Swift. And so I'm hoping this can be beneficial to others, because I try my best to talk my way through it, reason about things, look up the concepts, and really understand, what I'm consuming. But just remember that first and foremost, it is a raw learning experience that you're watching. So just be leery of that. That'll become apparent. But I say that just so you don't expect some kind of, instructional or some kind of seminar style, talking at you. It's not one of those. This is a legitimate learning experience that you're watching happen in real time. And my hope is that this is something that catches on, at least resonates with some level of, volume of people, because it's enjoyable for me. I think, doing it this way has given me a good structure for just repeatedly and consistently coming back to learn it. So it's cathartic for me in one sense. And then obviously, there's the whole learning process too. That's the real benefit. And so the aim here is to go through Swift. We are on page 528 of this 818 page book. So we're eating into it now. We're getting there. So we're going to go through this book. We're going to finish this up. That won't make us Swift experts, obviously, but we will have gotten a pretty solid, I'll say, look into the language, because this book is really fleshing out like all the features. And I like that. I mean, it can seem overwhelming at times, and we've seen, there's literally like 8 or 9 different ways to do a lot of these things, which is kind of wild, but it is very expressive. So I'm feeling good about the choice overall. After we get through this, we're going to work through a SwiftUI course specifically. So that's not going to be that's not going to be a Big Nerd Ranch guide. It's going to be a separate course that I purchased. So we're going to go through that, learn SwiftUI. Then we'll do some schema design for the application that I have in mind for my startup. And then after that, we're going to dive back into the books at that point, it'll be another Big Nerd Ranch guide, but specifically for iOS and Apple's platforms. So instead of deep dive into Swift, then that book will focus on Apple's platforms. And then after that, finally, because by then we should at least have some clue as to how to, start actually writing applications and not just like, back-end code or pieces of code like we're doing now. And so at that point, we're just going to start building the app. And so we'll actually build the product that I plan to sell, out on the open market. Yeah, I mean, it's not like an open source thing. Sorry. This is a for-profit venture. But I think seeing that and coming along for the ride, I think there is value there. So anyway, that's my intent with this stream. And if it sounds like something you're into, that you want to tag along for, then subscribe, brother, or follow me, or whatever platform thingy, whatever it's called, on whatever platform you're seeing this on. Do that thing, and I would appreciate it. And in return, I will keep my mug yapping about code and whatnot. Because I think eventually, after we build the app, this certainly won't stop. Our I really want to learn Odin, but I'm trying to. I mean, I can resist because Swift is more than enough for what I have in mind, and addresses my immediate need. But yeah, I'm just saying. After the fact, we'll pick something else and step through it. Anything that I can find a really good, because my only issue with Odin, I think, is that there's no. I just really like learning from books. Maybe after Swift, I'll feel differently because maybe through learning all of these different concepts, maybe that's a plus. So if I take that to Odin, maybe I can work up. Actually, that's not a bad idea. Maybe I could write a book on Odin. No, no, but I could make some examples to help people. So maybe we'll do that. Yeah, maybe we'll do that. That's pretty cool. But so the reason I bring up Odin though is Odin and V, as far as I know, I could be wrong. I bet C++ has it too, but as far as I know, just from my own knowledge, Odin and V are the only languages that already have like full support for Metal, which is kind of like I don't know, is it fair to call it like the Raylib of the Apple ecosystem? It's probably a little more complicated than Raylib, just from my short observance of it. But yeah, that's basically what it is. Metals is, and I heard they might port it to other platforms, so that would be cool. But either way, I do want to learn that because I really not anytime soon, but maybe like in 3 years or so, I do have this belief that Apple's headset, it's going to catch. We have no reason to believe it won't. It already has some pretty interesting utility about it that actually really caught my eye. And so even based off what it can do now, I just think it would be freaking awesome to be able to make what's there now better. So laying that groundwork now is a benefit to me. And yeah, so that's the long-term plan for this stream. Now, with that said, I hate to do this. But you can't. You make some choices sometimes. I thought I was ready, brother, but my bowels. It's TMI. I know. Don't worry. It's not that kind of stream, but I just need to take a quick break. Okay, I'm gonna be right back, and then we're gonna get in a solid 3-4 hours on this. Okay, so I just need 10 minutes, brother. I'm coming right back. So 11. See you at 11:43 CST. Okay, I'll be right back. Sky. Okay. That wasn't so bad, brother. Okay. Eat healthy, ladies and gentlemen. That's all I'm going to say about that. Okay, so had some wings last night, and I just shouldn't have. That's all I'm going to say. Now, yesterday, I think we kept. We're still doing the generic thing. I mean, I like I said, I appreciate the deep dive. I appreciate that aspect. And I don't have my background music on. Come on, brother. I appreciate that aspect of it, but it is really funky. Like I didn't use these in Go. And so it was my first exposure, it is my first exposure to this. And it is a little, like I get it, but like I said yesterday, I think I said 68% understanding, something like that. Anyway, we're going to pick it up right here because I know we got a little further along than this, but we'll just start here. Because I think that the concept before this, yeah, it was all a little fuzzy, I'm not going to lie, but yeah, we'll just pick it up here. Okay. Jay, are you ready? If I give you a pinky up, then give me a 30-second clip. Previous. Okay. Generic composition and opaque types. Oh, brother, forgot my water. Time to scoot. Boot, scoot, booty. Hot dang. Okay. Might be time for a mic stand. All right, now. Generic composition and opaque types. Opaque types were recently added. We just saw that yesterday. So that's just a little nugget. Generic data structures can compose with one another using protocols to build systems of types that elegantly describe more complex ideas. For example, think of an array of dictionaries, which might have a composed type like array, dictionary, and then inside the dictionary, string, and an integer. Sometimes you might want to hide some of the gritty implementation details of your compositions. To see what this looks like in practice, we will model a hungry human ordering toast at a restaurant. Begin with a food protocol and a food that conforms to it. Yeah, so we wrote protocol food and bread, which was somewheres. Near the bottom. There we go. Okay, so protocol food, which is one property. So to conform to this protocol, this would be the only requirement, a property called menu listing of type string, and it should have, or it should be a readable value minimally. And then struct bread. Here we say it must conform to the food protocol that we just declared here, or defined. I wonder what's the right term there, declared or defined. But that we wrote here, that we typed. So it has a additional property of its own, of kind, and then here's the menu listing to fulfill the protocol conformance. And that just returns the kind property inside of a string and then prints bread. So in this case, sourdough bread. All right, and then using a protocol to define the menu listing requirement allows you to write a function to accept any food. As you learned about in chapter 19, define such a function. What page is this? 528. I want to see what do they mean by that? Protocols. That was the reference. Okay, that's fine. Whoops. There we go. Okay, define such a function. So then we already did this one as well. So this was the func eat. So func eat, and then it's a generic. So we have that pokey syntax. T is our type placeholder. And this colon food says that the placeholder type, whatever we pass in there, will need to conform to, whoops, what the hell? Will need to conform to the food protocol. And then this course underbar here inside the tuple for the arguments, or for the parameters rather, that's our anonymous external parameter, so we wouldn't have to pass in, or we wouldn't have to define food as the argument we're passing. We could just pass it in inside the parentheses. So internal parameter name is food, and then it will be of type T. So that's just saying, or this would be a way of ensuring that what we pass in as the argument is of the same type as whatever whatever we declare it as whenever we actually call this and use it. So it's maintaining the type between what we pass in and the return. And that would also mean that whatever is passed in to food, since it's of the same type, and since this type conforms to food, so too will whatever we pass in, it will have to. And then we just return this string, I sure love, and then it would print the food struct from the instance dot menu listing, yeah, which would then print the full kind and the string. Ed Cusack. Oh, well, I will call him back. Ed Cusack is a recruiter, but all I can think of is John Cusack. Not like that, but just because I never heard of another Cusack until this guy. Okay, so we understand that. Using a protocol to define we wrote that. And then, we went through this func eat, so we just looked at that. And then we say eat bread. Eat bread, brother. So that's the function, and then bread, eat bread. Oh, I see. So that action, okay. Oh, no, okay. Well, I'll leave it there for now, but we'll come back. To keep things simple, the eat function will accept any type that conforms to the food protocol. Right, so that's all we're saying here. Or that's what we're indicating right here. Your console output should show the customer's reaction. So let's Command Shift Enter to run this bad boy. And then we get I sure love sourdough bread because of the string. And the kind up here, sourdough. And we're printing the menu listing, so it's I sure love sourdough bread. Okay. With this groundwork laid, things start to get interesting. Define a struct to model a restaurant and some nested structs to define the preparations of food it might create. Okay, so then we defined this whole thing is is a struct, right? So this is a type restaurant. Then inside it we have two other structs, slice food, and then same like our function, we have a placeholder type for the argument, and it must conform to food. And then the struct as a type itself must also conform to food, which means whatever we pass in should have, whatever type we pass in should have its own property menu listing to conform to food. And then the struct itself, the struct restaurant itself, oh no, we didn't say that. I was going to say the restaurant has to also have its own menu listing property, but that's not true because it's not, we didn't write this, so so it doesn't have to conform. Okay, so where did I see it? Oh, it's right here. This is, the pokey syntax throws me hard, like pause, but struct slice food. So we're saying, yeah, the type passed in, so the type of the eventual, I have to quit saying that. It's really, it's brain effing me a little bit. Whatever we pass in needs to conform to food. How about that? There we go. And then also the type slice food, since we have the colon outside the pokies here, food. So the sliced food struct itself must also conform to food. And it does because we have this property. Okay, we got there. All right, now, so we have the other one, and it's the same story here in terms of the signature. And there's our conformance. And then, of course, these menu listing properties are different. They both return a string as they should, or they both have type string, but they do different things, or return different strings. Okay, and then what else did we... That was it for that section. So nested within restaurant, you define new structs, slice food, and cooked food. Data structures that are generic over an ingredient that must conform to food. Data structures that are generic over an ingredient that must conform to food. Nesting these structs within restaurant. In this example, provides a nested scope for access modifiers. Oh my God. Oh. Pardon me. Thank you kindly. Okay. Data structures that are generic over an ingredient that must conform to food. I feel kind of nauseous. Maybe I shouldn't drink that coffee so fast. Nesting these structs within restaurant, in this example, provides a nested scope for access modifiers. Nesting these structs within restaurant, in this example, provides a nested scope for access modifiers. A nested scope for access modifiers. Okay. Which you will apply later. So, okay, so we don't know what those are yet. And models the idea that knowledge of cooking is in the domain of the restaurant staff rather than the public. Yeah, I read that yesterday and I really wanted to dig in there. So I hope they really let us dig in there. Otherwise, we'll go ask the Oracle. But obviously that's relative to the example, but I don't know why, but that really makes me think. It models the idea that knowledge of cooking is in the domain of the restaurant staff rather than the public. I really wonder why they're saying that. Okay. To complete the metaphor and let the restaurant take orders, implement some methods for creating sliced bread and toast. So within you define this is scope for access modifiers, which you apply later, and models the idea that knowledge of cooking is in the domain of the restaurant staff. Oh, I guess that means just because it'll be like, unless you're inside the scope of the restaurant, i.e. like inside the scope would mean you're on staff, like you're in the inner circle. you work there versus you eat there. Is probably what they mean. I'm probably thinking too deep about that one. But to complete the metaphor and let restaurant take orders, implement some methods for creating sliced bread and toast. So we did do this too. So we got our method here. So friendly reminder for anybody that forgot or has seen it for the first time, when we talk about functions and methods, all methods are functions. Not all functions are methods. So a method is a function that's defined within the scope of a particular type. And so since these two functions are inside the scope of this struct restaurant, these would be methods. We would call them methods available on type restaurant. Friendly little reminder there. Okay, so func makes sliced bread. And then we got no arguments here. So empty tuple. We have the arrow syntax. So we're saying it needs to return sliced food. Make sliced bread needs to return sliced food of type bread. Sliced food of type bread. Yeah. Huh. Where's bread coming from? Bread. Oh, okay, my bad. Bread is anything. Or it can be anything. So that's no different than writing the placeholder T. Okay, yeah, my bad. But just to be sure, so that means I should be able to do like food, right? No? Wait, expected what? Expected to complete generic argument list. I'm not sure what it has to be what that means. Sliced food. But that would already be the... No, wait, that's already a type. Sliced food is a type. Maybe that's... I'll just ask. Shit. I want to make sure that I have a decent understanding before we push on. What is bread in this context? If this is intended to be a generic. And let's just give it the whole. Oh, but we do have, wait a minute, let me think about this. We do have bread. Here's bread. And so, oh, okay, I think I get it now. Since, okay, so here's bread, right? Bread conforms to food protocol. And where's the sliced food? Yeah, so since sliced food conforms to food protocol, we also get access to this type. I think that's what's cracking, but let's see. Okay, so then might as well give it the whole, at least starting here. So bread is a specific type of food that is being used as a generic parameter for the generic structs and functions within the restaurant. Here's a breakdown. Okay, great. protocol food. This protocol requires any conforming type to have a menu listing property. Yep, got that. Struct bread. It conforms to food. Yeah, we implement. Yeah. Okay, but okay. So eat. This function takes any type that conforms to the food protocol. Okay, yeah. So that's how I should. That's the right way that, and I'll try to remember that so I read it out correctly. But that's how it should be thought of. That it takes any type. So T is T could be anything, just a placeholder, but it takes any type that conforms to the food protocol. It prints a message including the menu listing of the, okay. Using the generic function, when eat bread is called, an instance of bread is created. That's what I was wondering. Okay, so it's created, and since it's a struct, it's a value type, so that would be a copy. It's created and passed to the eat function. The function then prints the menu. Okay. And then nested structs within restaurant. Sliced food. So any type that conforms to food. That takes any ingredient type that conforms to food. It contains an instance of the ingredient and defines its own menu listing. Wait, sliced food does an instance of it? Sliced food. Okay. Cooked food, similar to sliced food. It contains yeah. Then methods. Okay, here's the one that I was questioning. So make sliced bread, return type, sliced food. Pokey syntax bread. This method creates and returns an instance of sliced food with bread as its ingredient. Oh. Okay. Here, bread is used as the type parameter for sliced food. Okay, I'm gonna have to ask you something else, but this method, okay, first creates and returns an instance of sliced food with bread as its ingredient. Cooked food. With that sliced food bread as its ingredient, this demonstrates nested generic types, where cooked food's ingredient is itself a sliced food of bread. Alright, so in this code, bread is used as a type parameter to instantiate generic type sliced food and cooked food. Bread conforms to the food protocol, making it a suitable type for these generic structs and allowing them to provide specialized generic mixture can operate specifically with bread. Okay, and then so my other question, so the bread type is accessible through the restaurant type. How? Through the protocol, right? The bread type is accessible through the restaurant type by using the methods provided within the restaurant struct that return instances of generic types initialized with bread. These methods allow you to indirectly work with bread through the restaurant interface. Make sliced bread method. This method in the restaurant struct returns an instance of sliced food bread. When you call make sliced bread, it creates and returns a sliced food instance where bread is the type of food being sliced. Make toast. Yeah, but bread is used as a type parameter. The methods make sliced bread and make toast provide a way to create and interact with bread instances wrapped in other food conforming types. So is I just have to be sure. Referring to the type bread that is defined, or is it a placeholder? Could be named anything. Okay, it is. Okay. Placeholder and generic definition of placeholder used to define a generic type that can be substituted. Here, ingredient is a generic placeholder. Okay, so I guess what I really wanted it to tell me then is, or what would really help me, is how like really just how it should be read, like in plain English. Like what is it? Just what is it doing? I think that'll help. Because I get what it's saying kinda, but it's like in different spots. So let's see if I can work that. Paste. Okay, so then in Swift below function, how would you read this in plain English if we're describing what it does to a noob like me? Okay, it creates a new instance of bread. It slices this bread, packages the slices into something called slice food that holds the sliced bread. Okay, no, maybe not. Oh, I mean, that's helpful, but okay, so but what is specifically, what is this portion of the syntax doing? So that slice food, bread. Because slice food is a type and bread is a type. Normally in a function, there would only be sliced food to indicate the return values. So I am trying to decipher how this should be understood. Arrow syntax, return type. Ooh, I gotta pee real quick. I'll be right back. Damn water running through me. Boom, shakalaka, laka, 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 laka. Okay. Oh, dang, it's a long answer. Okay. So we get that arrow syntax used in functions to specify the return type. In this case, the return type is, so that is, okay, so that's the whole type. Okay, that's what I was not, so I guess the, well, I don't have to guess, I can just read it. Okay, so understanding sliced food bread. Sliced food is a generic type. So we know that just simply by angle brackets. It means it can hold or work with different kinds of food. It's like saying a container for sliced food. Okay. Okay. That's what I really needed, or one part of it. Okay, so a container for sliced food. So I should think of this. Without specifying what kind of food it is. Okay. Bread. This part specifies that the generic type sliced food will specifically hold bread. It means that sliced food is being used here to contain slices of bread, not any other type of food. Okay. So, okay, so only. Interesting. Yeah, break it down, brother, because my brain's still like, scared. What? Okay, generic type. In Swift, generic types allow you to create flexible and reusable functions and types. By using a placeholder like t, you can specify that a type can work with any type, which is determined when the type is actually used. For example, array int, which means an array of integers, array string, an array of strings. Sure. Specialization. When you see sliced food bread, it means the generic type sliced food is being specialized to work with bread. It tells the compiler that this instance of sliced food will specifically deal with bread. Okay. Putting it together, when you see sliced food bread in the function definition, it means the function will return an instance of sliced food that is specifically designed to hold slices of bread. Okay. Think of sliced food as a generic sandwich bag. You can put different kinds of food in it, sandwiches, cookies, etc. When you write sliced food bread, you're saying this particular sandwich bag is specifically for holding slices of bread. Okay. Yeah, so I guess that this is really the thing though, so. It means this part right here. So it's a container. So this is the type. But it'll only work with this other type. Now, but okay, so in saying all that, does that mean of type? Does bread dictate what we can pass to the okay. I'll read it one more time. So this is a generic type. We get that part. This part specifies the generic type. So sliced food is a generic type, but bread specifies that the generic type will hold bread. Well, it'll hold. That's what I'm getting stuck on. What the hold? I guess in the instance, because they said container. So when you create an instance of it, slice food would hold. So this is the type. It'll return slice food. And that's the type it'll work with. And I guess okay, I get what it's saying now, but I just want to have it clarify that portion, because we are still, we're still passing in bread. So I just want it to, it'll make me feel better, basically, if it just explains that part. Return type does not dictate what you can pass to the function. The type of the returned value. Oh, and so, okay, so it could be, so bread in that case is inconsequential. It really just needs to be wait, where did it go? Where do we define it? Bread. Yeah, because it's the protocol conformance. So it could be any type that conforms to food protocol. Is that what we're saying? Return food. Let's see what this example it gave. No, bread in the return type slice food bread does not dictate what you can pass to the function make slice bread. Yeah, I get that. That makes sense. Instead, it specifies the type of the returned value. Let's break this down further to clarify. Here's the function signature again. It's like, here, dumbass. Here's the same thing I showed you earlier. What it means. Func make slice bread. This part defines a function named make slice bread that takes no parameters. Right. Return slice food, type slice food as a container of bread. This part specifies that the function returns a value of type slice food bread. A value of type slice food bread. So the whole thing is the type. That's the thing it's kicking me. It's going to click. It's going to click. Key points, no parameters, return type. Yeah. So generic types. The bread part of the slice food bread is used to specify the type. Oh, that's... Oh, okay, but I didn't ask it the right way. That's why it didn't give me that answer. Okay. Generic types. The bread part of sliced food bread is used to specify the type parameter. The type parameter. Right, so... Food. It tells the compiler that the generic type slice food is being used specifically with bread in this context. Function parameters in Swift. Function parameters are defined inside the, has empty. It takes no parameters. Let's look at another example to contrast functions that take parameters. Okay. So this would be the same function if it took a parameter. So generic type T, so that can be anything. And it would take a single argument of food. Okay. And it would return an instance of itself. would be of, I guess, of the same type as the food that you pass into it. Here, slice food is a generic function that takes parameter food of type T and returns slice food. This function can take any type of food as an argument and will return the corresponding slice food. Func may slice bread, return slice food, generic type bread, return slice food, food, bread. Creates a new instance of bread inside its body, so return. Okay, so that creates the instance, and we pass in bread. So, okay. I see, but bread does dictate the value you can pass into the return. Meaning the type of the value pass in as the that they would pass, I guess indirectly, it's in the body, into return slice food. Okay, so that makes sense then. Okay, the bread in slice food bread dictates the type of the value you can pass into the initializer of slice food. This being the initializer, so it ensures that the type of the value you provide to slice food is bread. Yeah. Okay. Slice food bread is a generic type specialized with bread. So I guess it's that other additional term that I haven't had in my vernacular, my Swift vernacular of specialized. Takes parameter of type bread. So this is the return type, and this is the type for the yeah. So actually I think I'll just save that whole thing. This is definitely going on the board. So generics and type, and then parameter type. Okay. Thanks, ChatGPT. Okay, so then it makes a bit more sense now. We got there. So if trying to think of how could I... That conforms to food. Struct. What's like a subset of bread? Breadcrumbs. Breadcrumbs. And it's of type food. Or no, not food. Of type bread. So I should get a inheritance from non-protocol type bread. Oh, you can't do that? From non-protocol. Inheritance from non-protocol type. Okay, so you can't do that. Oh wait, but I could do, I think. Let's do var. Crumbs of type bread. And, or no, wait, not bread. Or yeah, bread. Instance of bread. But then I don't need this. Breadcrumbs. Okay. And so now breadcrumbs is also acceptable here. Instance of no. But can I replace that with like here? Oh, but that's just an instance of. Yeah, so I really need a separate struct. But it wants it to be of oh, what was that noise? Some kind of it sounded like my wires were catching on fire. Okay, I'm really struggling with this. Or not struggling, but I'm trying to reason about how it... I mean, I get what it's saying on the type. I would just like to see it, but... We'll probably... I mean, there's plenty of examples here, so we'll just get back to it. That was a long aside, but... This was my main... My main thing was understanding that... This angle bracket notation, the bread... When it's in the function signature, it's saying that sliced food is still, this is still the return type. So that, fuck off, you fucking gnat, Jesus. Sliced food is the return type. Bread is the type for the parameter. So I was trying to, I mean, it's just not coming into my brain, but I was trying to create a different example where this would be different, the bread instance. But it doesn't make sense because that would need to change too. But that's the whole point. So really that's just the part that I need to remember. So if you see a generic like this, this is still the return type, and then inside the brackets would be the type for the argument, in this case food. So whatever you pass in would need to be of type bread. And so maybe I glossed over it a bit. The specialization. I don't know if they use that term themselves. But let's see if they did or not. Special. They did. Okay, good. So there we go. Yeah, so it just kind of got lost in the massive amount of knowledge we're gaining, brother. Okay, so you define a placeholder type named element in the declaration. No, next page. Go stack and, or let's just read this whole. Yeah, okay. So we'll start from here to get there. Okay. Because clearly I glossed over this. So generic data structures. You're going to create a generic stack. Okay. Last in, first out. So LIFO. So we get that part. We created the stack. A struct has 3 elements of interest. The items stored property is an array. Oh, no, I thought that was generic info. They're talking about the example. Okay, so we'll start here. Which simultaneous. Okay, note that pop returns an optional integer because the stack might be empty. You create a new stack instance, push 2 values on, try to put them off. Okay, I remember that example. We worked through that. Returns. Where is the specialization part? Your stack is useful, so we still have this piece of code. It's up here. It's mutating func pop. Mutating func pop. Okay, here it was. So this is the generic stack. All right, you define a placeholder type named element here. And also in the push, where's the push? Oh, here. And so that'll be of type and it'll need to conform. Okay, so then you define a placeholder type named element in the declaration of stack. Yes. Swift syntax for declaring a generic uses angle brackets immediately following the name of the type to enclose the name of the placeholder type. So element, okay, so that's where we're at. The placeholder type element can be used inside the stack. Placeholder type element can be used inside the stack structure anywhere a concrete type could be used. Oh Lord. Dum. Okay, so that element. By defining the placeholder type element and then using in place of int, you've made your stack generic. Now you have a stack of any type at all, not just integers. There's now a compiler error where you instantiate a stack because you have not specified what concrete type should be substituted for the placeholder type element. The process of the compiler substituting a concrete type for a placeholder is called specialization. Oh, this is where it said, okay, that's why we didn't really dig into it. The full details of specialization are outside the scope of this book, but the short summary is that it allows the compiler to make your app faster because the compiler is able to output code knowing the specific type in use. Okay, so fix the error by specifying that int stack should be an instance of stack specialized for int. Oh, so okay. So I get, okay, so it was showing us how we can make one a generic like especially generic, because element is just it's a placeholder. There's no, we didn't define like a element type like we did for bread further on that other example. And so specialization, well, is that right? Specialization. Let's read that again. The process of the compiler substituting a concrete type is called specialization. Okay, faster because the compiler is able to output code knowing these specific types. So maybe that's really the final question: is what is the? Let me see where I'm at. Yeah, specialization with bread. When you specialize sliced food with bread, as in sliced food bread, it means that T is replaced with bread. The initializer sliced food bread expects an argument of type bread. Okay. So 2 questions. In this case, what else other than bread could be passed in? Okay, it is the only, okay. Deeper dive into why func makes sliced bread return type of sliced food, with the parameter type being bread. Return sliced food bread. That's literally the same one. Sliced food bread is a specialized version. Okay, so that is what's happening. Specialized version of a generic type. Okay, so yeah, it's interesting. It threw me because they said it's outside the scope, but then later we write it anyway. You know what I mean? Like we ended up doing that anyway. So not that it's their fault. I'm just saying. No, but okay. So that makes sense. So initializer bread, therefore. Yeah, here's the question. If you want to be flexible, accept different types of food, you would need to change the function to be generic as well. So maybe they just meant the explanations behind specialization is outside the scope, but otherwise, oh, struct sliced food. Oh, I see. So then this would say we could pass. Oh. Okay, so that's helpful. So that's the generic version of that bread. Make sliced bread. Where'd it go? Here. Yeah, so here we're saying it can be of any type. One argument, and it needs to be of the same. Well, really what you pass in will dictate the type. And the return value will be of type sliced food. And the input into the body of the function, food would also have to be of the same type. Slice food. Okay. Cheese. The book alludes to gains if you use what compile time or okay, so that the performance, that makes sense that it would just be, it wouldn't, I don't know how it would affect it during runtime. So especially refers to compile time specialization. Yeah, okay, so beyond that, I think we're good. I do have one other before we move on there. Does Swift have a runtime? Does Rust have a runtime? Is the Swift runtime a separate? Okay, good. All right, yeah, it's included in binaries. All right, cool, fair enough. So it's kind of like Go. Okay. So, but Swift doesn't have, I thought it had, what do you call it? Reference counting? Swift garbage collected? Each object in Swift has a reference count that tracks how many references or pointers. Performance. Oh, okay. Deterministic deallocation with arc objects are. Okay, well that's, I mean, that's pretty, it's beyond me anyway, for now. But I was just curious. Okay, now we're back. I get what's cracking here. So yeah, it just wasn't sinking in that we were talking about two different things. So this would be an example of using generics and then within the umbrella of generic specialization. So this is a way to speed up compile times if you already know, for example, that like you wanted your method to, well, in this case, if you wanted your return type to only be effectively fed values that are of type bread. Yeah. Yeah, okay. I think we're set for real this time. All right, now let's go finally back to where we were. Generic composition. Oops. Opaque types. We were cook food. We got here nested within restaurant. Oh yeah, that's where we were. Okay. Nesting these structs within restaurant in this example provides a nested scope for access modifiers, which you will apply later, and models the idea that the knowledge of cooking is in the domain of the restaurant staff rather than the public. To complete the metaphor, let the restaurant take orders implement some methods for creating sliced bread and toast. Okay, we did that. And your make sliced bread function returns a specialization of the sliced food generic structure for which the ingredient is bread. Oh, that's what I meant to ask. Yeah, one more thing. Dang it. So here. In this context of Swift, ingredient. Ingredient is a generic type constrained to conform to the food protocol. Oh, I see. Because, okay. But we could call it anything. Generic. Yeah. Ingredient can technically be any type as long as it conforms to the food protocol. This design allows you. Yeah. Okay. So it's yeah. Okay, but ingredient could be changed to gradient, for example, and there would not be any consequence in terms of functionality, since it is just a placeholder term. Okay. So I guess you just have to, well, I guess the white text gives it away, but I mean, were it to be an actual like object or thing, well, I guess that's the point. It can't be a thing. Like I can't call that bread. I can call it bread. See if I get my would it do? So is this allowable? Is the below allowable? Oh, I didn't give it the rest of the... And here is the below in Swift, specifically using the using the placeholder in since it is also an actual type. Is used in the slice food struct within the restaurant struct. Slice food. Okay, so it won't, or it will point out the conflict. So that's okay. That was really my main question. The generic placeholder in sliced food struct has been renamed from bread to food type. What? Where? Generic placeholder in the slice. Oh, make slice food. Where's that go? Gotcha. Okay. So that's why. Okay. That answers it, because as long as it's where. Okay, so I like that. So that's a good thing. Just wanted to make sure that there is a, or not make sure, but it's good to know there's a control point there, because at least, yeah. I mean, there's some kind of, the compiler helps you out, I should say. So if there's a conflict, it would make you aware of it, and then you could change it. Because as the code gets longer and you're thinking about all kinds of food stuff, coming up with terms and whatnot. Okay, so that's cool. All right, sheesh. Okay, it finally sank in through like 8 inches of thick skull. All right, your make sliced bread function returns a specialization of sliced food generic structure for which the ingredient is bread. Your make toast function, in turn, returns a composed type, a cooked slice of bread. Your make toast function, make toast, in turn returns a composed type, a cooked slice of bread. And so this is composition, I guess. That's what that. So yeah, so this is specialization. This is specialization and composition. Generic composition, yeah. Slice. Turns a specialization of slice food. Okay, so that's how they refer to that instance, a specialization of slice food. All right, no arguments, type slice food. The parameter should be of type bread. And then after this instance of sliced food, is returned, then make toast is return value needs to be of type cooked food. And the input that's passed in should be of type sliced food, and what's passed into sliced food should be of type bread. Okay, so it's just, all right. Man, Pamela ding dong. Okay, so let sliced bread equal, yeah. Okay, I think I understand it. It's just, it's like an ogre, it has layers. Okay, so then a cooked type. Wait. For which the ingredient is bread, your make toast function turn composed type. A cooked slice of bread. Okay, so there's our composed type. Cooked slice of bread. Or rather, that's composition represented in the signature of the return type. So cooked food, sliced food, bread. Okay. Yeah, it does make sense. Now your restaurant goer can order toast for breakfast. Nice. So okay, we actually didn't actually type this, so now we're finally back. But I'm glad we restarted, because yeah, I was not getting it. Okay, so let restaurant equal restaurant, an instance of restaurant. So we get all of these. It's a value type, so we get a copy of the struct inside restaurant, and then let toast equal restaurant dot make toast. Okay, brother. And then eat toast. And then wait, so eat was can be of any type as long as it conforms to food. And what I pass in will drive the type. So these will be the same. So it should be I sure love. And what are we passing in? Oh, if we eat toast, toast is equal to restaurant make toast. Okay, so it should be wait, where is it? Make toast return. Yeah, I sure love sourdough bread again. Eat toast. Food. Sourdough. Yeah, okay. Your console output. Oh, right. Your console output should show the customer enjoying toast after the bread they ate previously. Oh, no, okay. I screwed it up somewhere. That's not what I'm getting. Let restaurant equal restaurant. What's the problem, brother? I sure love a slice of sourdough bread cooked to perfection. Run it again. Okay, there we go. Good old Xcode. I was wondering because it looked correct. All right, so there it is. So I sure love a slice of sourdough bread cooked to perfection. And from eat, we got, where's eat? God dang it. Oh, is it? It was a method. Okay, eat. Okay, so that's where that string's got. I sure love the food.menu listing. So I sure love a slice of sourdough bread. And that would be food.menu listing. Okay, sourdough and then bread. And the other string comes from the cooked food. And since we have the return type of cooked food, okay, so that's where it's getting added on. So cooked food, or make toast returns cooked food, and we pass in sliced bread. And so eventually we get the eat output. I sure love sourdough bread, which is basically there. And then we get the rest of the string, cooked to perfection. And then since that's the return value, cooked food, that's where it ends. Okay. Hot bibbity. All right, man. You have modeled the ability for a customer to eat a slice of bread, plain or cooked, by way of the restaurant's generic cooked food type. Right. As programs become more complex, the complexity of generic data structures can increase. The number of types in this exercise is limited to respect your time and your typing. But at each step, you should keep in mind the compounding complexity you would face if you needed to model other foods, such as butter, egg, or a composed combined food ingredient, or functions like make French toast. A make French toast function might return an even more deeply composed generic type, such as cooked food, combined food, bread, egg, butter. Oh Lord. Such compositions are not far-fetched. What would happen if the restaurant changed its toast recipe to cook the bread first and then slice it? Make this change. Aye. And we'll do that right after this bathroom break, brother. That's right, I'm going again. Don't eat Popeyes, ladies and gentlemen. Well, I shouldn't say that. Don't eat Popeyes at midnight. I was weak. I shouldn't have done it. BRB. See you at... What time is it? Oh, we got a long way to go today, brother. I'm going to call it 1:15. At 1:15 CST. Alright, that's easy to see, right? Alright, be right back. All right, brother. Man, my stomach be hurting. Where's my water? Oh. I told the nice gentleman that called he can call me back, so if he does call, I will just take the call. Then y'all can hear me finesse this. No, I'm playing. I actually don't even remember what position it was for, but I'm sure he'll tell me all about it. It's weird looking for jobs now because it's like you don't really. I mean, you can look. I'm embellishing a bit, or I'm exaggerating a bit, but it's really more like, at least in the technical field, seems more like you're better off just, relying on a recruiter because, I don't know. I mean, it's been I got laid off February 15th of this year, and I got my job in May, which I don't start till July, but so that was February, March, April. Yeah, so not quite 3 months, not quite 90 days. But in that time period, I probably applied for, hell, I don't know. I'll go out on a limb and say 300 jobs, which might be on the high end. Let's just call it 200, maybe 200. And got 0 calls back, 0 emails from any of those. I mean, I would know just because, like, literally none, like that I applied to, that I went searching for. But I've had plenty of, I think I've had a decent amount. It took a while because I wasn't on LinkedIn initially, so I had to, set up my profile, blah 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 blah. But it seemed like once one recruiter found me, plenty started hitting me up. So now I've probably had maybe 12 to 15 inquiries I've had. And one of those recruiters he's brought me a lot of different opportunities. Some I've said no to. It just didn't sound like, it was more like systems programming stuff, which that wouldn't be good for me. I don't have enough experience to come in and not fuck shit up, basically. I don't know, it just didn't interest me. But my point is that, none of those that I applied to, I got a response from, but there's still opportunities, but it's really more just about people finding you, I guess. So I don't know, you just got to make yourself available. But yeah, I can only imagine, like on LinkedIn, when you apply to jobs, they show you, which is nice, but it's also indicative of a bit of like oversaturation, maybe. I don't know. But you can see how many people have applied to the jobs. It gives you a percentage profile, like how much of a fit based off the skills that you tell that you have versus the job description. So it's really nice and insightful, but it's almost, at least it seemed useless, because the only, like, the job that I got and all the opportunities and interviews that I've had brought to me have been via, recruiters. So anyway, that's just an aside. All right, so now where were we? We were making French toast or something, brother. What were we doing? Now, let them eat toast. So we did that. Okay. Modeled as programs become more complex. Oh, right, we were here. Okay. What would happen if the restaurant changes toast recipe to cook the bread first and then slice it? Make this change. Funk make toast. Wait, what? Make toast. Get rid of cooked food, sliced food. Let me get rid of that. sliced food. So I guess if anything, you could, except for this part, like the bread part, because you're telling it on the input, but you can almost kind of think of it as just algebraic almost, at least in the way it is communicating to you the values being used, like at each step. Because I get the composition part, because literally has the function names, right? So first we start with the input of bread, and then on the next layer out, we're working with cooked food, so we know that the bread produces cooked food, and then cooked food is what is used by sliced food. It's always with these damn onions, inside out. That's what really helped me with SQL, you know, the stored procedures. Like, I had no issue ad hoc logging into a server and like writing, because we would often have to fix data on the fly or like do database maintenance stuff. That's easy enough, but the stored procedures, they would be so long, like the ones that especially that the Fox Pro developers would write. And you get all these like declared, these declarations up top. So everything kind of with SQL like just starts from the center, and then you like work your way out within the scope of a given thing. But yeah, seeing a lot of commonalities there. Okay, so return. How did I change this? Oh, okay. Return. So I got to get rid of that now. And then now what? Bread. Let cooked bread equal cooked food bread. Let cooked bread equal cooked food. Cooked bread. And then we return what's cool about this though is, I mean, from a library author's perspective, or even if you were like, let's say in a year and a half from now, the app is doing well, I want to hire some punk ass kid like to work on my app, maintain it. That's the dream anyway. But if you played your cards right, I mean, you can make this very clear cut for somebody, and just in terms of like, hey, get in there and we're bringing on a new like, I don't know, if you had a restaurant, you want to update your menu, we're bringing on a new set of food, like I want you to add some new methods so they can use the menu, interactive app, whatever, to build their meals or something like that. You could really, because of the autocomplete and the way it's structured, it's almost self-documenting once you understand what the fuck you're looking at. But yeah, that's a different matter. All right, so return slice food. So we return just like the signature says. So it's literally this. This is the control point for the return value. So it's saying the same thing. It's an instance of sliced food, and it's using cooked food, which is using bread. Yeah. Okay. The signature of your function has changed, but the meaning of its output has not. Eating the returned food has the same result. Okay. Let's see if you're right, brother. I sure love a slice of sourdough bread cooked to perfection. Sure enough, they're correct. Changing the order of the steps in Make Toast, even to one that yields a food with the same menu listing, has resulted in a different return type for the function. A different return type for the function. Oh, this versus the, yeah, okay. Where do I leave off? This could cause cascading changes to other functions, unfortunate enough to be relying on the return type of Make Toast. On the return type of Make Toast. Oh, okay, I see what you mean. Other methods that might use, yeah, okay. To be relying on the return type of make toast, yeah. Such as some imaginary make buttered toast function. This brings us to the crux of the problem. The composition of the type of toast is an implementation detail of restaurants. Other functions do not and should not need to know about the precise composition of this type. After all, the eat function is happy with any argument that conforms to food. Okay. The solution is to not expose the type at all. This can be done in two ways. First, you declare your functions as returning food rather than their precise types. Oh, bro, you could have told, man. Yeah, go ahead and make this change. While you are at it, restore the implementation of make toast so that bread is sliced first. I should know by now. That's how they do you. But I mean, it definitely works. I haven't felt like I've learned this much on a single topic, like just sticking with it and going real deep, brother. To this degree, probably since SQL. Because even with Go, I just kind of, it's like, yeah, you understand it, kinda, like, I don't know, 60%, but you just go grab examples, change it, test it over and over, but this has been good, so this is good. But private struct slice food. Oh, so we're just making them private. Private struct. Okay, so this is what they meant earlier. So here's the access control. I see. Func make slice bread. What do you want me to do to it? Change it to slice. Oh, just to food. Yeah, that's a lot easier, isn't it? Because in the end, at the top level, that's what we're asking for in terms of the conformance. Private struct cook food. Slice bread. Make toast. Yeah, what are we doing here? So we can get rid of this long ass. Whoops. No. There we go. There we go. I was wondering where the hell my delete button was. Alright, so get rid of this. And also now, just food. Oh, bro, come on. It's so much better. Let me get rid of these. Okay. DD, I. Let sliced bread equal sliced food bread. Okay. Then return cooked food. Return cooked food. Sliced bread. Okay, make toast returns type food. And then sliced bread is equal to an instance of sliced food. Passing in an instance of bread, and then we return an instance of cooked food. Okay. Codifying the idea that sliced food and cooked food are implementation details of the restaurant type means marking them private. Okay, so that would be another nugget, a good one to remember in terms of like how to speak about things. So codifying the idea that sliced food and cooked food are implementation details of the restaurant type means marking them private. Okay. You allow this by removing them from the signatures of non-private methods. You allow this by removing them from the signatures of the non-private methods. So these two, these are public, or at least within the same file. So the explicit composition is gone. Okay, I get that. And then what? Food. A return type of food means that make sliced bread and make toast could return any kind of food. True. We could use a where clause, right? A return type of food means that make sliced bread and make toast could return any kind of food. Different calls to the function could return instances of different food conforming types. Return is a different, yeah. That means that a hypothetical variant make toast function could decide whether to slice the bread twice. And there's that. Wait a minute. Func make toast. Return type food. Slice bread. Oh, now you changed it on me. So now it's a var. Slice bread. Slice food bread. And then we have this conditional. So if bool random. Random. Oh, so you'll get back true or false at random. And so if it's true, it would slicked bread. Don't eat the slicked bread, it's terrible. Sliced bread. So if true, this would run. If it's false, then it wouldn't, and that would give you your concept of maybe it gets sliced twice, maybe it doesn't. So sliced food, sliced bread equals sliced. God damn it. Sliced food. Food. Sliced bread. What? I misspelled something. Sliced bread. Sliced bread. What's the problem? If bool.random, open that up, closes the. Yeah, what's the error? The fuck? That's cannot convert value of type to expected. Oh, they must var sliced bread equals sliced food bread. Alright, maybe it's one of those intended error things. This sample implementation would either return a sliced food bread or a sliced food bread based on a bool.random. This is a flexible approach, but it may or may not be what you want. Right now, a caller of this function must account for the possibility that make toast might return items with different menu listings from one call to the next. Wait, but hold on. Got an error here, brother. Expected argument type bread. That's what I have. Func make toast. Return food. Var slice bread. Slice food. Food. Instance of bread. If bool.random Then do this if it's true. So sliced bread is equal to sliced food. Food. Cannot convert the value type restaurant sliced food bread. I wonder why it's saying that. It shouldn't be saying that still. Why does it need to be... Cannot convert value. Maybe I missed something up here. Return cooked food, food sliced bread. Return... Make toast. Yeah, I must have missed something here. Func make toast. Return type food. And then we get rid of the let and return. Oh, I am. Var sliced bread. Wait, what the hell is it telling me? It just told me to... Okay, let sliced bread equal sliced food bread. Okay. Return cooked food sliced bread. Okay, so then before this was here, was it good? I sure love it. Okay. Okay, it's working right now. And then a return type of food means that make sliced bread and make toast. So these two guys could return any kind of food. That means that a hypothetical variant make toast function could decide whether to slice the bread twice. Maybe they don't want me to write that. I don't know what that means, but it's not valid code. That means a hypothetical variant. This sample implementation will either return a sliced food bread or a sliced food bread based on bool random. It's a flexible approach, but it may or may not be what you want. Right now, a caller of this function must account for the possibility that make toast might return items with different menu listings from one call to the next. Two diners ordering toast together might be surprised when one of them gets toast made with doubly sliced bread. The second way to hide the method's return type is to return an opaque type, which is denoted by the sum keyword. What? Func make sliced bread, return some food. Okay, what the hell does that mean? So, okay, so it's an opaque type. Let me... I have to highlight this. Okay, so some food in both methods. Okay. By returning the opaque type, some food, you instruct the compiler to figure out what the function's return type will be. You instruct the compiler to figure out what the function's return type will be, which requires that your function will always return the same type. And to hide that type, information from humans writing code that calls the function Wait, okay, I read that wrong. By returning the opaque type some food, so some food is an opaque type. You instruct the or it's made opaque by using the some keyword because it is an actual type as well. You instruct the compiler to figure out what the function's return type will be. Okay, which requires that your function will always return the same type, and to hide that type information from humans writing code that calls the function. It'll always be the same type, and to hide that type info. Okay. Sorry about that. Wide awake. All right. This way, visitors to the restaurant can rest assured that Make Toast will always return the exact same kind of toast without needing to actually know about its composition. I get that. I mean, I don't get the example, the double slice thing. I don't get why that was thrown in there, but okay, opaque types can only be used as the declared return type of a function or computed variable, not as the function argument. Okay. Okay, only on the return, so that's another. Opaque types can only be used as the declared return type of a function or computed variable, and not as the function argument. So we couldn't use it here, like inside. Or even here. Yeah, okay. But it can follow the arrow syntax, and it can follow, what did it say? A closure? Or a computed, where'd it go? Or computed variable. Yeah. So I could do that. That's computed, right? Sum string. A sum type must specify only any object, protocols, and or base class. Sum type must specify only any object, protocols, and or base class. Okay, so since that isn't a protocol or any of those other things, but we can here because food is a protocol. Okay. Okay. Opaque types can only be used as the declared return type of a function or computed variable, and not as a function argument. But in this capacity, they give you the simplicity and privacy of a protocol type with the specificity of generic programming. May not be what you want. Yeah, I'm ready to be done with generics, if I'm being totally honest. Opaque types can only be... Wait, I read that part. It's function argument, simplicity. Okay. They are especially useful for framework developers who want to use complex type compositions without exposing the complexity to users of the framework. Okay, good. We're not writing a framework, so hopefully we can just limit our use of these till we're a bit more seasoned, a little more salt pep on us, you know. You will see a concrete example of this strategy in chapter 28. Okay, or by chapter 28. Generics are an extremely powerful feature of Swift, and this flexibility comes at a cost of syntactical complexity. Boy, does it. Tell me about it. If generics have not sunk in, do not fret. You should have led with that, brother. I've been fretting for 4 days now since we started. They are an abstract concept. No, I mean, it makes sense, but we had to beat the hell out of ChatGPT to get there. So, but it's, well, plus the book. It does make sense. The opaque types, I'm pretty sure I get what they're describing, but again, I won't be touching that for a hot minute, you know. So I'm okay with not having a deep understanding. Kind of like with the extensions, I felt like that was full on grasp, like 100%, because I have use cases in my head that pop up just by reading, you know, what they are, what they do. This, you know, it kind of, there's a lot of information, but so they're an extra concept. They take lots of exposure to truly appreciate. Okay, I'll take your word for that one. Take your time, go back over the stat class you wrote in this chapter and try your hand at the challenges. It is also perfectly okay to move on and return to this chapter later. And that's, ladies and gentlemen, is what we're going to do. And man, did I mention not to ever eat Popeyes? You have any idea how much I regret that decision last night? Oh my gosh, man. Okay. I'll be back again. What time is it? I still got a solid hour in me, so yeah, we're gonna get through another chapter, so stick around, but take this opportunity to you know, stretch your legs, support me emotionally, remotely from where you are, and we'll be back at 1:52 CST. All right. Okay. Took a little longer than I thought it might, brother. But we're back. Okay. Good Lord, I hope that's the end of it. Oh man. I just need to uninstall Uber Eats altogether, seriously. Okay, alright. Where were we? Okay, yeah. We're moving on, finally. Moving on. Generics are an extremely blah, blah. Okay, yeah. Challenges we'll come back to at the end of the book. For the more curious, understanding optionals. Yeah, okay, we'll read through it. Optionals are a mainstay of all non-trivial Swift programs. Optionals being our, like, let something, and then on the type we can do like string with the question mark. And so that's how we can handle nil values. If there's potential for something to be nil, it's how you can handle it. So if it's not nil, with your logic, you can, execute the code just per usual. If it is nil, then, do something else. Handle it a different way. Fail gracefully. Okay, so optionals are a mainstay of all non-trivial Swift programs, and the language has a lot of features that make it relatively easy to work with them. Agree? Under the hood, however, there is nothing particularly special about the optional type. It is a generic enum with two cases. Enum, optional. Oh, it's a generic, cool. Now that we know what that is, so wrapped would be our placeholder type in this case. And then our two cases, none. And I wonder if I can do this syntax because, yeah, you can. Okay. Yeah, so it's either none or some, which I wonder if that's the same as some. Probably not, because it's not red for one, so it's not a keyword in this context, it's just a case. So this is an optional of a given type called wrapped. Return none or return some of the optional type. Oh, so it itself is an opaque type. I see. Yeah, some wrap. Okay. As you probably expect, the none case corresponds to an optional that is nil. In fact, nil is just another name. Oh, sorry, I didn't say it right. Nil is just another name for optional.none. You slick son of a gun. I see. Optional.none. Optional. And then dot puts you inside the body, and then none. Maybe I'll write it like this so it's not as... There. None. Man, it's all coming together. Optional.none. It is a value of type optional in the same way that true is a value of type bool. It is a value of type optional. In fact, nil is just another name for optional.none. It is a value of type optional in the same way that true is a value of type bool. Okay. Which is why you cannot assign nil, to variables of non-optional type. Which is why you cannot assign nil to variables of non-optional type. Okay. Okay. The some case corresponds to an optional that has a value of type wrapped. Because that's our placeholder there. So The sum case corresponds to an optional that has a value of type wrapped because the associated value of the sum case is a generic placeholder. Yeah. You are able to create instances of optional to wrap any type. Okay, because the associated value of the sum case is a generic placeholder, you are able to create instances of optional to wrap any type. Frickin' smart. I get it. Okay, so we can pass whatever here. So that can be of any type, as we learned. And it will either have a value or not. Yeah, hot dog. Okay, but so then well, no. Okay, that makes sense. Let's just see what they say, because I don't want to start guessing on this section, because I have no idea where they're going with it. Because the associated value, most of your interactions with optionals will use optional binding and optional chaining, but you can also treat them like any other enumeration. For example, you could switch over the two cases of an optional integer. All right, let's take a look here. Make it a little bigger. Let maybe an int, and it's of type optional int, equal 10. Switch statement. So switch on maybe an int. Maybe an int. Case. Dot none. Oh, I see. Okay, yeah. So that's like saying if it's nil, because we inherit, or that's not the right word, but whatever, we get access to the enum optionals cases because it's of type optional. So I can call this dot none instead of nil. Print maybe an int is nil. And then the other case let dot sum value print maybe an int is the escape character, string interpolation value. And we get, I don't know, it's hard to see, maybe an int has the value 10. But if it was nil, we would get maybe an int is nil. But if this wasn't optional, we couldn't do it. Yeah, okay. This is not usually necessary, but it is nice to know that optionals are not magic. They are built on top of the same Swift features that are available to you. That is, yeah, that's nice to know. I guess my thing is that I'm curious about. I'm glad that was nice and short. So let's ask the Oracle. In SwiftLang, how does Swift know that to the optional type is defined in the Swift standard library as enum optional wrap. Yeah, okay, we just saw that. Swift uses syntactic sugar to make working with optionals more convenient. The keyword nil is a literal that represents the absence of a value. Yeah. And it maps to the .none case of optional. Okay. The optional type and nil literal are deeply integrated into the Swift language, enabling seamless use of optionals. Here's how it handles it. Internally, mapping nil to none. When you assign nil to an optional, Swift translates it to the none case of the optional enumeration. Okay, so I guess that it's just in the compiler somewhere. Don't worry about it, brother, is what I'm hearing. Okay, that's fair. Fair enough. I won't. Okay, then this is usually, or not usually necessary, but it's nice to know. Oh, wait, read that. Okay. Protocol extensions. Oh, snap, brother. This should be good. Two of my favorite things that we've learned about so far. Switch statements, too. I think those are really cool. Okay, so a dominant software programming paradigm of the past few decades has been object-oriented programming. OOP is a powerful and I'm just kidding, I won't keep saying that. OOP is powerful and well known, and developers have an intuition for what this style means for code. Yeah, they do, and it's always different, which I find jarring and worrisome and all kinds of stuff. You never know. I must have interacted to this point in my career with, I don't know, 1,000 developers. It's a decent sample size. Well, granted, I didn't ask each from this question, but realistically, I don't know, maybe 15 to 20, and you just always very different answers, and you're like, what? What? But then you go and look. I mean, it makes sense because even the guy that coined the term came out, like, I think it was, I don't know, a decade later or something, way later, and said, like, y'all took it the wrong way, brother. That's not even what I meant by OOP. So now, like, I've settled into the camp of OOP. I just think inheritance, and I don't want to deal with it, basically. Traditionally, the OOP uses classes to model data and methods to modify and process that data and communicate with instances of other classes. Swift supports OOP, though its approach to this paradigm is non-traditional, given that enums and structs can replace many typical uses of classes in OOP. Thank goodness. Swift's value... Wait, who just texted me? Oh, thanks, babe. You're a peach. Okay. Where the hell? The paradigm is non... Oh, yeah. Swift's value types are powerful and flexible. Indeed, they are. Yeah, enums have easily been my favorite, I think, even though I just said the other thing. So it's like enums, extensions, and then protocols. But that pretty much runs the gambit. Well, in structs, but structs are... Well, they've been in every language that I've interacted with. All the C-based ones, so I'm not sure that's necessarily very specific to Swift, but either way, yeah, I like all of the... They did a good job with how they interact, I'll say that. Okay, on the other hand, Swift can add power and flexibility to all types via protocols and protocol extensions. If you want multiple types, even value types, to have shared behavior, you can make them conform to a shared protocol. Right, that's awesome. No direct inheritance needed. Oh shit. Yeah, blow that up, put it on a t-shirt, baby. All for, well, I won't highlight that, but, and as you will see in this chapter, you can even provide a default implementation of your desired behavior using a protocol extension. An extension for a protocol? This chapter will explore using protocol extensions to add new behavior to all types that conform to a given protocol. No shit, dude, that is cool. Wow. Yeah, that's impressive. Okay, to customize the behavior of the Swift standard library and to add default implementations of protocol requirements to your types. Add new behavior to customize behavior of, okay. Pardon me, ever so kindly. Okay, modeling exercise. Before you begin exploring protocol extensions, you need a protocol. You need a protocol and some conforming types to experiment with. You're going to write some very basic code that will let you track workout data. Okay. Create a new macOS playground called Protocol Extensions and begin with an exercise protocol. Protocol extensions. You got it, brother. Playground. Protocol. Extensions. Learning. Create. All right. Oops. There we go. All right, protocol. Exercise. Exercise. First property is a mutable variable indicated by the var and not let, and then calories burned. Here's our property name in camel case, as they've dubbed it, and it's of type double. And we're saying it needs to be, well, if we just say get, we're saying it needs to minimally be a readable value, and then with set it also needs to be a writable value. And then we do another second one, minutes, so same thing of type double, and same, it needs to be a readable and writable value. So to conform to exercise protocol, those two properties with those two types, readable and writable, is required to conform. The exercise protocol has two read-write properties to model the number of calories burned and the minutes spent performing the exercise. Create two structs to track workouts, one for using an elliptical trainer and a second for running. Okay. Struct elliptical workout exercise. So this is how we tell it that the type elliptical workout must conform to the protocol exercise. So it looks just like a type annotation or declaration, whatever. And we need our two properties, which they pop right up because it's, I guess it is inheritance still, but it's coming from the protocol, it's not like class inheritance. I'll have to look back and see what term they used, but either way, we have access, or the autocomplete, because it knows what they are, because we associated the protocol already. Var minutes of type double. All right. And so we learned that if we don't explicitly define it, the getter is just implicit, and it's just like the code that runs, so it can be different every time. So we don't have to necessarily, in the conforming type, indicate a specific way to get the value. And by making it mutable with the var keyword instead of let, we fulfill the set, the writable requirement. But if we did let, it should give me an error, right? Maybe? Yeah. Okay, so that's how we fulfill the writable. So it needs to be mutable. So it has to be var. And that should go away. Yep. All right, so what was next? There, guy. Struct running workout of also conforms to exercise protocol, var calories burned, var minutes, and then we have meters that is specific to the running workout type. So we conform by having what's required, but we're still able to add additional properties on top of it. So it doesn't have to mirror it, it just needs to fulfill the base requirements. You define two new structs that both conform to exercise. Each has calories burned and minutes properties that will be set when the instance is created. Running workout also has a meters property to keep track of the distance run. Meters is not required by exercise, but recall from chapter 19 that extra properties or methods are perfectly acceptable. Create an instance of each of these new types. Okay. Let elliptical workout equal elliptical workout, calories burned 335. It's a decent workout. It's about a cupcake's worth, one cupcake. And then I guess it doesn't matter where I let running workout equal running workout, calories burned 350, minutes 25, meters 5,000. 5,000? Wait, how many miles is that? Oh, that's fine. 3 miles. Okay. 3.1. Oh, duh, that's the, yeah. Where is the, yeah. Now that you have a protocol and some conforming types, you can start to add more functionality to these types. Now that you have a protocol, and, yeah. Extending exercise. A natural question to ask about an instance of exercise is how many calories were burned per minute of exercise. You can use your knowledge of generics and type constraints to write a function that will perform that calculation. You can use your knowledge. All right. Func. Calories burned per minute. Minute per minute. E being our placeholder type, and colon exercise being our insistence that that placeholder type conform to the exercise protocol, whatever it may be. So this means I can accept any type that conforms to the protocol exercise. And then for, in this case, so now we're inside the parentheses. So we're defining the function signature, more specifically its parameters. So for would be the external parameter name So the function caller could use for colon and then the argument to pass it in. And exercise, in this case, is our internal parameter name. So callers must use for to pass a value in internally inside the body of the function. You still have to use the internal parameter name. And we're saying that the single argument must be of type E as well, meaning same as the type of calories burned per minute itself, but that would be driven by whatever we pass in. So these will be the same, E and E. And then arrow syntax to indicate whatever type we want the return value to be will be listed here. So in this case, we want to make sure we get back a double. So arrow syntax double. And now we open up the body of the function, bust it wide open, and then return keyword and then our return value logic. So exercise calories burned. Exercise calories burned. Oh, okay. So here. So we'll get that passed in. So that's how it knows. Okay, so exercise dot calories burned, and we know that it'll have calories burned because it has to adhere to the protocol exercise, which dictates that you will have a property called calories burned, and it will be a type double, and we'll be able to read it and set it, and this is the return type, and that matches double, and so everybody's happy. Okay, so divided by exercise dot minutes, and same story with minutes. So that's how we get our association there. And now what you want to print calories burned per minute for. So there's our external parameter name from here. And then we pass in our constant elliptical workout. Wait, what did you pass in there? Yeah, elliptical workout. And print calories burned for running workout. Command Shift Enter. All right. Wait. Calories burned per minute. Oh, per minute. Really? I mean, I don't know. I'm acting like that's true. I don't know if it's true, but 11.2 basically on the elliptical, 14 running. I mean, it makes sense that running would be higher for sure. More muscle activation, but okay, so the body of the function. Where are we? Here. Calories burned per minute for is a generic function whose placeholder type must conform to the exercise protocol. Yeah. So here. You made calories burned per minute for generic so that you can call it with an instance of any type that conforms to exercise. Oh, right. Yeah, okay. So you might have different kinds of workouts. I see. Okay. To burn with any instance that conforms to exercise, including elliptical workout and running workout. The body of the function uses two of exercise's properties to compute the calories burned per minute here. So just one divided by the other. There is nothing wrong with calories burned per minute for, but if you have an instance of exercise, you have to remember that calories burned per minute for function exists. There's nothing wrong with calories burned per minute for. What do you mean? Wait, is that all one? But can I still see if I do dot? Oh, so I don't see it. I don't see the method. Oh wait, it's not a method though. It's just function. Okay, I see what they're saying. Okay. But you have to wait. Exists. Okay. It would be more natural if every exercise had a calories burned per minute property. Yeah. Okay. I see what they're saying. Then I could dot and then see it. It would be more natural if every exercise had a calories burned per minute property. But you do not want to have to copy and paste the same implementation into both elliptical workout and running workout and any new exercise you might create. True. That would be a pain in the ass. You cannot add the property definition to the protocol, as protocols themselves do not define the implementations of properties and methods. Yeah, so they're saying you can't, in a struct, you can have a computed property that could do something like this, just like we're doing with the return value. But actually, does it let me, calories burned, var burn, and it is still a double. How do you, I think this is how you do it. Pow. Is that allowed? Cannot find exercise. Oh, yeah, this would just be. Is that allowed? Hell yeah, brother. We're fucking programmers now. Okay, so yeah, so that's how you could do that. But you can't, so this is a struct. You can't do this in protocols. So I couldn't just mosey on up here and do that. It only supports the signature aspects, basically. But with protocols, it can, apparently. So let me get rid of this. That ultra burn. But you don't want to have to copy. Yeah. You can add the property definition to the protocol as protocols. Oh, you cannot add the property definition to the protocol as protocols themselves do not define the implementations and properties and methods. Instead, write an extension on the exercise protocol to add this new property. Okay, so instead of the function itself, extension exercise var calories burned per minute, menu per minute, type double, return calories burned, minutes, menus. Why the hell? I must have seen that in a dream somewhere. Okay, so, and now this extension exercise. Okay. And we'll get rid of these. Protocol extensions use the same extension keyword as extensions on other types. Protocol extensions can add new computed properties and methods that have implementations, but they cannot add new requirements to the protocol. Okay, that's definitely getting a highlight and a note on protocols and what is allowable. Okay. Let's read that again. Protocol extensions can add new computed properties and methods that have implementations. They can add new computed properties and methods that have implementations, but they cannot add new requirements to the protocol. Oh, so you can add functionality, but it won't enforce it in the same way if we wrote it inside the body. Okay. Protocol extensions also cannot add stored properties. For the uninitiated, so the stored properties var something int equal 4. Like, you can't do that in a protocol. It's only the signature, basically. So you can't do that. Okay, so, but you can do that here in structs. You can do it in enums and classes, of course. Add stored. Okay, but they cannot add new requirements. Protocol extensions also cannot add stored properties, as extensions in general do not support stored properties. Properties and methods added in a protocol extension become available on all types that conform to the protocol. Oh my god. Getting no air to my brain. I think that was a myth that got debunked, but I'm going to roll with it. So properties and methods added in a protocol extension became available on all types that conform to the protocol. Much like the restrictions on generic functions, the implementations inside a protocol extension can only access other properties and methods that are guaranteed to exist. Much like the restrictions on generic functions, the implementations inside a protocol extension can only access other properties and methods that are guaranteed to exist. Okay, yeah, so we can't pull in like other generics unless they were specialized with the bread thing that we looked at for like 5 hours. But it couldn't just be the ingredient, like up in the air, any type ingredient type placeholder. So now that you have deleted the calories burned per minute for function, your playground is showing errors where you call the non-existent function. Your playground, delete the function calls and instead access the new calories burned per minute property on elliptical workout and running workout. You got it, brother. Print elliptical workout dot calories burned elliptical workout calories burned. Yeah. Oh, there it is. I'm just blind. Hell yeah, that's way easier. Okay, so running workout. Running dot calories burned per minute. Look at that. I like that a lot. I like it a lot. That's give me a programming boner. I'm telling you. I know it's inappropriate, but a programming boner is in not any way sexual, just to be clear. This ability to use a protocol extension to add use a protocol extension to add features to all types conforming to the protocol is incredibly powerful. Boy, is it. And it drives many features of the Swift standard library. I was wondering how, I'm like, man, how do these jokers that write these iOS apps get these features out so quick? Boy, I mean, my gosh. No, that's really cool though. That's impressive. I do like that a lot. And it drives many of the features of the Swift standard library. You will learn more about standard library usage of protocol extensions in chapter 25. I'm telling you, chapter 25 is going to change our lives because we've been hearing about it over and over. much of the culmination of all of his knowledge is coming to a head in chapter 25. And we are on chapter 22. Yep. Okay, guys, I'm going to wrap it up right there for today. And I'm going to go stick an IV in my arm and try to gain back all the fluids I've lost. So, sorry for all the breaks today. Normally, I would not apologize out into the ether to random people I do not know. But I feel like today was over the top. So I apologize for that. Now, as always, if you would just take a look on screen there and make sure you drop a follow. Would really appreciate it. Make sure you come back tomorrow because we're going to be doing it tomorrow again, roughly 11 a.m.-ish for another couple of hours. 11 a.m. Central Standard Time, to be clear. And then also, if you're into Halo video games, competition, or just me, okay? You don't have to tell me. I'm just saying. If you just want to be around me more, I also do a stream at 9 p.m. Central for a couple of hours. 9 p.m. Central every night. It's a Halo Infinite stream, 100 days of ranked Halo Road to Onyx. So I'm currently at Platinum 6, which is which is 8 tiers away from Onyx. And I got 40 days to do it. I think today's day 60 on the dot. Crazy, man. When you start numbering stuff and like when you start doing something every single day, I've realized it's really, I was telling my girlfriend this the other day, I've lost all concept of time now. My time is now defined in episode numbers. Like, oh yeah, that happened back on, episode 29. But anyway, check me out, guys. But if not, I hope I see you back here tomorrow because I'm going to be here. Whether you're here or not, I'm going to be here. Feel me? Thank you. Have a good day. Take care of yourselves. Go get a good meal. Eat something that's good for you. Trust me. Take it from me. Don't suffer. Go out, get some sun, vitamin D, and, hug a loved one. Bye, guys. See you tomorrow.